Actually, I will take one diagram. For this diagram, I will explain all the concepts. Now you don't write anything. First you understand what I'm going to do. Then I will give you sufficient time to write. Okay. So suppose this is any bar, and this side any force is acting. So that force I divided by the area, and I got my sigma x. What is sigma x? Stress in x direction. Then this side was also loaded. Actually this side is also loaded, because otherwise only one side, if you will apply the force, then this block will go in this direction. There is no force, then there is no stress. Both side the system has to be loaded properly. So I applied actually loading fx, but I divide by the area and I got my sigma x. In same way I applied the loading fy, but I divide by the area and I got my stress sigma y. Sorry, this is also sigma x. In same way sigma y and sigma y. Now see, right now whatever is given, this is the complete defined stress system. What I mean, in x direction whatever is the stress, so it's like if you cut the section here, then add this section, how much stress is acting in this direction, we know that is sigma x. If you cut the section like this, stress acting in this direction, we know that is sigma x. If you will cut the system like this, then in this direction what is the stress acting, that is sigma y. If you cut the system like this, then like this, okay, sigma y. But what if you will cut the system at any inclination, okay, then perpendicular to the surface, guys, perpendicular to the surface, there will be one normal stress. Like here sigma x is normal stress, then for this purpose also you will be having a normal stress. Now let's understand one physical behavior about this. Imagine why this is important, like where are we going to use this part. Imagine you have an aeroplane, and this is the wing of the aeroplane, and this is flowing, because whatever you are learning you should know little bit you should know where to use. So whatever I am knowing, I will explain. See, this is flying in this direction. So what will happen, the air will hit. So now just little bit rough idea I am giving. Okay, actually it is more detailed study, but I am giving just little bit idea. Now consider this spring and this wing as a block like this. Let me draw the 3D block like this. Okay, see how our thought process develop. So from here whatever wind is coming, that wind will apply a strong force. Okay, now which force I will consider? I will consider drag force, because the drag will take the lift in this direction. Okay, so you can consider our wing is loaded now. Okay, at the same time air is flowing above the wing, so which will generate lift also. So you can just contrast I am giving. So upward I am getting lift, and in this direction I am getting drag. So it's like here also you have loading condition. Now you remove lift and drag concept, because I am taking only in terms of force x direction and force y direction. So now this entire beam, this entire wing may fail. It may break here, it may break here, it may break here, it may break here, or maybe the system may break like this. So we have different angles at which wing may break structurally. Okay, you know there is something called experimental aircrafts. If you'll go to Wikipedia, you will come to know there is something called experimental aircrafts. Those aircrafts are used to check propulsion system, to check new propulsion system, to check new structures. So we have experimental aircrafts. So suppose this is the experimental aircraft, and we are trying to test the wing by flying them in real life. So one force is here, one force is here. This may break like this also. Basically, as a simple like childhood manner, you can see that wing will break from this part, but reality is wing can break from anywhere. So we have to know that for a given block, this is fx. Okay, this fx I can convert into stress, this Fy I can convert into stress because I know clearly the area. So force by area will give me stress properly. But if I want to check that whether my wing will break at this angle any time in the flight or not, whether my wing will break at this location any time in flight or not, it's like when the aeroplane is standing in the parking, that time no problem. When the aeroplane is flying or doing all kinds of maneuvering, then in different types of maneuvering, different types of air will hit the aeroplane with different speeds. So our Fx Fy values will change. So of course our longitudinal and lateral stresses will change. So that you can simply you can do by your hand calculations. But you have so many oblique planes, okay, you have to create mesh, right? So in different attachments you will be having different angles. So now I am coming to the main point. If you have a wing like this, and already you know that in this direction you have sigma x, in this direction you have sigma y, then at any angle, because it is simple part, at any angle if you want to find out normal stress and shear stress, how will you find out? So for that we are going to develop this kind of idea, general two-dimension stress system. It means, see, actually we have sigma z also, but sigma z we are not doing here because it will make the portion very lengthy. So we are only considering sigma x and sigma y. So your answer about sigma n will look like, see, I will prove everything, I will explain everything, but just now I am giving you the future idea that what we are going to do. It will look like sigma x plus sigma y by 2 plus sigma y minus sigma x by 2 cos 2 theta plus tau sine 2 theta. This kind of answer we are going to achieve for sigma n. In same way we are going to get for tau theta. So now let's start in very fresh way how to approach and what is our main motto here. So I will erase this part. Already you have taken the theory. Okay. So now you do one thing. Actually, one physical feel I wanted to give. That's why I took this this example. Not only this example, you can also bother about if you have aeroplane and here you have landing gear. So when the landing gear is hanging, so you just consider this part which is hanging. Don't consider other mechanisms here. So in that you can see this part is hanging downward. So already one tensile stress is being developed in this leg. Tensile stress is being developed. At the same time, air is also hitting. So this air is also hitting. So because of that, one load is acting in this direction. Okay, it is attached here. So of course, to stop this load, reaction will be in this direction. So anyway, we got a loading condition here, right? So for this loading condition, we can calculate stress in x direction, stress in y direction, and then again we can find out stresses in any oblique angle, like system will break from here or not, what will happen, like that.